Hi, everybody. This is lesson number 2 in Math 100, Liberal Arts Mathematics. Lesson 2 is all about logic, propositions, inverses, and other things. So let's get started, right? And this is going to be a rather complicated section already. I know have just started this course, but try to pay close attention to every detail of this lesson on logic and propositions. Okay, so here we go. Oh, I forgot to mention, in a moment I will share my screen so that you can fill in blanks of the notes for lesson 2. So make sure that you have your notes for lesson 2 ready. And one more thing, the background is my hometown of Kobe, Japan. It's a lovely place. I wish you could see it. I wish I could be there right now. All right, so lesson 2, here we go. Okay, so propositions and logic. Again, this is fundamental to mathematics. And in fact, you may be used to just mathematics as being with numbers and involving calculations only. But in a deeper sense of the mathematics has to do with things to be learned. That's the original word from the Greek language. And it really has to do with theorems and proofs and theorems and proofs. If you remember your high school geometry class, perhaps that will give you a better taste of what mathematics is. And underlying everything mathematical is this idea of logic and propositions. So this is what this lesson is all about. Right? So first we'll be answering questions like, what are propositions? And then how do you use them? Or how are they used? So this really comes to, coming to the best conclusions or the more precise conclusions using what we call formal logic. Okay. Now, in logic, statements are called propositions. Now, these are mathematical objects, and we treat them as like numbers. Like if you have numbers, some numbers are larger than others, and we order them, we add them, we multiply them, we subtract them, and so on. So numbers are certainly mathematical objects, but in formal logic, or sometimes called meta-mathematics, the statements are also objects. And so we can combine them, negate them, assign values to them, and so on. And so these operations lead us to some basic ways of finding what we call propositional truths. All right, so the first thing is, the first requirement, a proposition must be a what? Complete statement and declarative sentence. You know what declarative sentence is as opposed to interrogative sentence or exclamatory sentence? Basically, it has to have subject and verb. Man, this sounds like an English lesson, right? Well, grammar has a lot to do with mathematics and logic, but we are not going to talk about English nor grammar. But it does have to have a subject and verb, right? So so I will come back to this in just a moment. The negation of a proposition is a statement or a proposition that always have the negation of a proposition always, I should be has here, has the opposite truth value from the original proposition. And I guess I should mention what the truth value is. Okay, there are basically two truth values. Every declarative sentence should be either true or false. Okay, so T or F, these are the truth values I'm talking about. So the negation of a true statement would always have to be false, and the negation of a false statement has to be true. That's simple. Now, of course, it's simple when you think about it right now, but as you go in to dive into the world of logic, you'll see that things are a little more complicated sometimes. Okay, all right, so let's take a look and see what we can find out. Okay, so Let's take a look at this sentence here. The senator does not oppose a ban on gun control. Ooh, what in the world are we talking about? Okay, the senator does not oppose a ban on gun control, right? So you know what gun control is? It's basically the opposite of the freedom and the possession and the purchases of guns and so on. The gun control has a connotation of the negation already, right? And then we have a ban on that. So that means we don't want to control guns. Then opposing a ban is sort of a negating the ban. So that means this is sort of for gun control, does not. So how many negative words are there? So sometimes the negation could be quite a complicated thing. Okay, let's try to figure this out. When you are for gun control, think of somebody who could be a gun control. Who is for gun control? Okay, in terms of the parties, the Democrats are more likely to hold or to support gun control than the Republicans, right? Not always, I understand. Okay, so this will be sort of somebody like a more progressive kind of person who is not so crazy about everybody having guns, right? A ban on gun control is a more of a conservative standpoint. Oppose would be maybe a more progressive or more liberal stand, and not is more conservative, right? So what does it say? Well, does this person, what do you think? This senator, and we'll talk about this in just a minute again. The senator is probably in favor of gun possessions. Now, why do I say that? Okay. So maybe a way to think about this is this: there are so many negatives here that it's hard to figure this out, right? So maybe you can think of this: does not oppose. Now, does not oppose is not exactly support, but does not oppose is a double negative. So it is, in a sense, in terms of black and white, or in terms of positive or negative. Does not oppose is similar to support. So you could replace this idea by saying the senator sort of supports a ban on gun control. Okay? Now remember, gun control is to try to restrict the possession of guns, and so ban on gun control would be to free up people to have guns, right? So this senator supports sort of the not having any kind of a control on guns, and so the senator is probably in favor of a of the freedom to own and sell and purchase guns. So even if we're talking about a simple negation, and we'll practice this in a moment, but negatives could be quite confusing. All right, so watch out for double, triple, and quadruple negatives. All right, and then to make things a little more complicated, we have, and this is just a part of natural language and a part of the world of logic, two types of what we call quantifiers. One is called a universal quantifier, and the other is called an existential quantifier. Okay, so this is a sort of an easy thing to remember. When we say a universal, that means every or all. Okay, you can say, for instance, all dogs are animals. Okay, so you're using a universal quantifier there. And an existential quantifier is a term like there is, okay, or some. If you say some dogs are white, you are giving making an existential statement. Okay. Not existential in the sense of philosophy, existentialism, but this is called an existential quantifier. Okay, so these things, I'm pointing these out because these two terms, or these two types of quantifiers, make negation somewhat difficult. All right, so pay attention, close attention to this. Let's negate each of the following. You know what, maybe we should go back and practice this. Simple one. I said the negation of a proposition is always going to have the opposite value, right? So if I say I am a student, Okay, that is a good proposition. Remember, you have a subject, you have a predicate, which is a verb. I am a student. This part is called the predicate complement, nominative complement. And so the opposite of this, I am a student, is what? It's very simple, right? I am not a student. Now, you couldn't say, for instance, I'm a teacher here. That would be not an opposite, because it's possible that somebody is neither a student nor a teacher. And it's also possible that somebody is a student and at the same time a teacher. And so you don't want to make a comment about, what else this person can be. Right? So I am a student. The opposite is I'm not a student. So this is a very simple type of negation process. Now, let's go back and look at these statements with quantifiers. And all X are Y, right? I'm going to give you a little more specific statement because that makes it a little easier for us to understand. Let's say, I've used this before. Let's say X represents dogs, okay? And Y is the predicate, cute, okay? So now, what does this say? All X are Y. That means all dogs are cute. You know what the opposite of this is? It's not all dogs are ugly, or it's not no dogs are cute, because it's possible that some dogs are cute while others aren't. If only half of the dogs are cute and if others aren't, this would be false. And so would the statement, no dogs are cute. Those are both going to be false. And remember, you can't have both the statement and its negation false or true. So in this case, the correct way to negate this is, and maybe I should say, all dogs are cute. The opposite is, what is that? Some dogs are not cute. Or more extreme way of saying this is, there is at least one dog that is not cute, okay? There exists at least one or some dogs are not cute. So that's the way you are to negate the statement. I'll try to summarize this in just a minute, okay? Now, this statement, some X or Y, using the same X and Y values, I would say some dogs are cute. Now, remember, this is an existential statement, and that means there exists at least one dog in the whole world that is cute. That's what we mean by some. It means there exists at least one. So to negate this, if somebody comes to you and say at least one dog is cute, how do you negate that statement? Well, the negation would require a big burden of proof, because then you would have to say all dogs are non-cute, or in this case, no dogs are cute. Okay, I hope you understand this. Think about how you would dispute the claim that some dogs are cute. Okay, in order to dispute that and prove him or her wrong, you would have to say no dogs are cute. For the first one, if somebody does come up and say all dogs are cute, then to prove him wrong is easy. You have to produce at least one dog that is not. Okay, all right, and then oops, go down here. If somebody makes a claim, remember, this is universal, this is existential, and the word no is universal. But if somebody says no, X or Y, no dogs are cute, then you say, wait a minute, that's not true, because you don't have to prove every dog is cute. All you have to do is, it's not true, not all dogs are cute. No, that's it. So if somebody says no dogs are cute, basically the claim is every dog has a property of not being cute. Okay, so the opposite is no, there's at least one. So some dogs are cute. All right, now, one of the things about mathematics is we try to make things abstract, okay? So we have specific examples here. Now, the question is, can you formulate the general statement here? Can you try to make this into something much more precise? What's the opposite? What's the negation of all X or Y? Okay, the answer, some X are not Y. Okay, and this fits the statement, some dogs are not cute, right? So the opposite or the negation of all x are y, or every x is y, is that some x are not y. Notice here, if you start with a universal quantifier, the negation would require an existential quantifier. That's one of those characteristics we'll see. If we start with the proposition some x are y, okay, then the negation is no x are y. So again, the opposite of a existential statement turns out to be a universal statement. Finally, you start with the no x, which is a universal negation. What's the opposite? Some x are y. And so again, the negation of a universal quantifier or statement, it turns out to be an existential quantifier. Okay, so it's maybe it's confusing, right? Yeah, it could be confusing, but I hope you can understand this. Some statements are easier to negate. Others, especially with the ones with the quantifiers, could be more difficult. All right, let's go to the end of this page, and then we can take a little break. Conditional statement. What is a conditional statement? Conditional means you have the word if. Okay. If P, then Q. These conditional statements are also kind of difficult, and it gets into more complicated. All right, so you could also say P implies Q. Or you could say, if you really want to say that a Q is implied by P, or a Q is a necessary consequence of P or something. In this case, P is the assumption. It's called the hypothesis, or more formally, antecedent. Okay. Now, you could call the P hypothesis because that's the part we are assuming, not hyper. Let's see if I can erase this. That would be nicer. And sometimes my computer acts up, and there you go. Okay, so hypothesis. And then Q is called the consequent. It is also called the conclusion. All right, so hypothesis, conclusion, antecedent, consequent. The word, if you have two propositions like P and Q, you can form, a conditional statement. If P, then Q. You could also combine them in two different ways: conjunction and disjunction. So P, and what is that? This is the word and this is conjunction. Okay, so the conjunction is the statement P and Q. So this is like like multiplying two sentences or two numbers. P is a statement, Q is a statement, and P and Q is a new statement. It's called the conjunction of P and Q. And so this is true. Now imagine thinking about two statements. When is the combination, an and combination of both of these true? Well, if that's true only if both P and Q are true. Okay, I know this is only lesson 2, and we are getting into some serious logic situations. And if this comes out easy to you, if it feels this easy, that's great. If it's not, if it's quite challenging, that's okay. Many people already find these things quite challenging. Okay, the second one, the disjunction, is the or statement connecting P and Q. And so this is called disjunction of P and Q. And this is true if at least, let's see if my computer can keep up with this. Okay, true if at least one of them is true. So hopefully this makes sense. Let's say P is a statement, I am old, and Q is the statement, I am a man. Okay, P and Q would say, I am old and I am a man, basically saying I'm an old man. P or Q would say either I'm a man or I am old. So that would include old men and women, and now it could include old men and women, and it could include men, whether it's old or young. So these are two different populations. Okay, so in terms of going to the second page, let's stop here for a moment because there are a lot more things about conditionals I will have to explain on the second page. And so we can take a little break and then we come back, or you can go straight to the second part of this video.